Hi there, this is exercise 6A. It's year 12 further maths, and we're looking at something called the chi-squared test of independence. And already I've got something a bit weird there. This is the symbol, the Greek letter for chi, and it obviously looks as if it's spelt chi, but it's not, it's chi. And for some strange reason it's called chi-squared, so you'll just get used to the fact that it's called chi-squared. And this chi-squared test of independence, sometimes called association, is a specific test that we do, and we will see chi-squared a couple of other times in a couple of other places. But this particular test is a chi-squared test for independence when we're looking at what are called contingency tables. And you can think of contingency tables more or less as two-way tables that you saw when you was perhaps doing GCSE maths or something like that. So let's have a look. What is independence or association? Well, first of all, it's the idea that one variable isn't affected by another variable. Now, I've described this as using what's called nominal data. Nominal data implies it's got a name, a quality, sometimes described as qualitative data. Qualitative data. And by that I mean the kind of stuff you get in the two-way table. So you might say, for instance, boys and girls, and you might have some idea of the number of boys and number of girls who do certain things. So that it might be their sports they like to play. It might be they like to play football, they like to play cricket, and they like to play rugby. And perhaps these are the three sports I've given them a choice of. But it might be I have a difference in the answers to these. Do you like these sports? Given they are a boy or they are a girl, and you might be looking for those. And if there is a link between these things, if for instance this is like 50 and this is 2, and this one's similarly biased, this one's 20 and this one's 3, and this one might be, I don't know, 15 and 14, these two might be very, very similar. So doesn't have to necessarily be all, it might be just we ask all these boys to pick their favourite sport, all these girls to pick their favourite sport, and you kind of see that there's something going on here. It's not the case that they are randomly separated, and that may well lead to some idea of them not being independent, these two ideas, this idea of sport and gender. So thinking about that then, this being a test for independence, this is my first example, and we are looking at a two-way table, and it's the type of degrees that people do, whether they do what's called a BA, an arts degree, a BSc, a science degree, and some students when they go to university to get a mix of the two. So it might be a course which has an element of science and an element of, say, essay writing. So on that basis, they then looked at the number of extroverted people, really confident people, if you like, and introverted people, if you like, shy people. And at first glance, you look at this and you think, well, there seems to be more people doing the arts degrees who are extroverted, the confident people, and less people doing doing those degrees if they're introverted. And likewise, it's the other way around for science. So you might argue that it seems to be the case that people doing arts are extrovert, people doing science are introverted. Now the only question is it enough of a difference to be sure? So let's talk about our hypotheses. We write these as H0, the type of degree and personality are independent of each other. Notice it's a very wordy description. And H1, the alternative, is that the type of degree and personality are not independent of each other. Now we've seen hypothesis tests in normal math, so this is not new. It's the wordy nature of this, and you're going to have to write that out, I'm afraid. You can also write these out in terms of the word association. So if you did that, just be aware it would say type of degree and personality for the top one are not associated. So the idea of independence and association, this means a link, if you like. Are they linked or are they independent? These are the opposite way around. So if you said it the other way around, just be aware we'd have to word it the other way around. Anyway, let's have a go at an example then. We first of all get this table that I showed you before, and we need to know how many of the what we'd call be row totals and column totals. So these are the row totals, these are the column totals, and then overall it seems that I've got 82. And these are the data I've got here is kind of the data I would have got if I'd gone out and collected it myself. It's called the observed data. And that, as opposed to what we want to find out, is the expected data. Now, this is an idea of, given the fact I had 44 extroverted people and I had 30 introverted people, we do a little sum, and I'll show you the sum. We basically times those two numbers together and divide by the total number of people. And that gives us an estimate of how many people we'd expect. If this was kind of randomly thrown in there, we'd expect 16.10 people to have been extroverted. And we do that for all the others as well. This one, 14.49, by the way. What I've done, and I want you to check this calculation, I've done the 27 times by the 44 divided by the 82. It's always the same trick. You do the row by the column divided by the overall total. And I got 14.49 for that. Now I want you to pause the video for a bit and do the other ones. So yeah, this one would be where you do the 44 and you times by the 25 and you divide by the 82. 44, 25, 82. So do all them all and then pause the video. Okay, I hope you've done them. So if you haven't, do them now. If you have, then I'm going to show you the answers. So I've got 13.9, I've got 12.51. The one I showed you, I got 13.41, and then 11.59. And these are called the expected frequencies. Now there is a good thing actually. The calculator will tell you these. But when I say the calculator, I mean the Texas TI-84 calculator. The calculator will tell you them, but sometimes they ask you to show how you work them out. So you definitely need to show this calculation more or less every time. Of the 6 here, I bet in the exam they'd say, explain why this extroverted expected frequency is 16.1. And you'd go, right, that's because 44 times 30 divided by 82 is 16.1. Let's move on then. So now I've got my expected frequencies. I've got to do a little check, and this is important. If any of them are less than 5, I have to combine the rows or the columns together to make it so that I get all these expected frequencies to be more than 5. If they're not, I've got to do something about it. So just write that down. The expected frequencies must be more than 5. If they are less than 5, we have to combine the rows or columns to make them more than 5. This one, none of them, look at these numbers, all of them, like that one, 11.59, it's more than 5, it's more than 5. All of them more than 5, so I don't have to do anything. That's good. Now, this is my formula then. I have to go through this procedure of doing the observed value minus the expected value. I then square that answer and I divide by E. This is the formula they give you in the exam. I repeat, the good news is this value is usually, we can just do it on our calculator. But for now, I'm going to go through it. So let's have a go at this then. So we'll have to nip back between the two different pages and see, and see what each one said. So initially I'm going to use the 19 value here and the 16.1 figure here. So that's what I mean when I say the O minus the observed minus expected. So initially, remember I'm doing O minus E squared, and I'm going to divide by the E each time. And the E each time will change. So the first one is 19 minus 16.10. I square it, and I divide by that 16.10. And I've just done these on my calculator to make sure it speeds up a bit. It's 0.5224. Now as I do these, I want you to check the answer each time. The next one I'm going to do is the 15 and the 14.49 figure. Notice I take the equivalence numbers each time. So I'm going to do the 15 minus the 14.49. Again, each time remember to square it, it's dead easy to forget. Divide by that new figure, 14.49. And again, check that you get the same as me. Pause the video as and when you need it. Now I think it was 0.01795 or something, but I've rounded this to 0.0180. And the last one is, and this time it's the 10 and the 13.41 that I'm going to use. So I'm going to write down here 10 minus the 13.41 squared divided by the 13.41. And again, what do I get? I get 0.8671. So that's the first three numbers done. Doesn't matter what order you do these in, because at the end we're going to add them together. So now I'm going to go on to this bottom row. I'm going to do 11 and the 13.9. So again, I've got 11 minus 13.90 squared divided by the 13.90. And when I've done that, I get 0.6050. I hope you're still checking. The next one is now the 12 and the 12.51. So it's 12 minus the 12.51 square it and divide by the 12.51. And I get 0.0208. Now you'll notice some of these are bigger than others. So the bigger they are, the more effect they have on the value of chi-squared, this weird letter. And the last one, if you check, it's 15 minus 11.59 squared divided by the 11.59. And that, according to me at least, is 1.003 and a bit, 33 I wrote down. So you now have to add up all these values. And notice it's a slightly curly x, and it's called chi-squared. And when you add up all these figures, so type these 6 numbers into your calculator, I get that it adds up to, and I'm just looking now, 3.0366, or I suppose I could round this to 3.04 to 2dp, or 3 sig figures, I suppose, really. Now look, this value then we look up in the critical value table, and I'll show you that now. But before I do, actually, I need to also work out the degrees of freedom. Now, degrees of freedom is effectively lets you know which part of the table to look in. So you'll notice it relies along this formula, m minus 1, m minus 1. This is where we've got a table which is m by n. Doesn't really matter which order you call them, but one of them goes across and one goes down. So by that I mean here I've got, this is a 3 and a 2. This is a 3 by 2 table, I suppose. So my m in this case is 3 and n is 2. And I repeat, it wouldn't matter if you called those the other way round. But notice what I'm going to do then. I knock 3 minus 1 is 2. I times that by 2 minus 1 is 1. I've got degrees of freedom, get rid of that. My degrees of freedom then for this calculation is going to be 2. And you can see 2 minus 1 equals 2. So this is what my degrees of freedom is called. Sometimes this is gives a letter V. Well, I'm sure that's probably another Greek letter, but it looks like a V. So anyway, you get 3.04 and 2 degrees of freedom. So this is the critical values table, which I've taken from the formula book for further maths. Now remember what we've said. We've said in the question that we're going to test it at the 5% level, and we had 2 degrees of freedom. So we use those two pieces of information. Remember what I said, V equals 2, degrees of freedom is 2. We look along there. And a bit weirdly, we have to go to the 0.95 value. So even though it's 5%, this means 5%, because obviously 95% and 5% make 100. So we don't look here, we look here. And this value here then is the critical value. So I'm just going to write here, critical value equals 5.991. Now remember what our chi-squared value was. Chi-squared was, I'm trying to remember now, 3.04. So 3.04 is less than 5.991. So we write, do not reject H0. Do not reject H0. Let's see what my official answers have said. I say official, my dodgy answers. Do not reject H0. And my wordy bit of this says insufficient evidence to say that the subject choice and student personality are not independent of each other. It's a bit clumsy, the wording, but that will do for now. Now, just be aware that in class I need to show you how to use this calculator, because it makes life a lot quicker. So we've seen one example. It's taken us 15 minutes to get there. So in class we'll go through how to use the calculator to speed things up a lot, because you don't really want to do all that work every time. So for now, that'll do. So thank you very much.